Using aluminum wire on a boat dock raises numerous safety concerns that should not be overlooked. Firstly, aluminum is susceptible to corrosion, especially in the marine environment where it is exposed to salt and moisture. Over time, the wire can weaken and become unreliable, posing a significant safety hazard. Secondly, aluminum has a lower electrical conductivity than copper, requiring thicker wire to carry the same amount of current. This can significantly increase the weight and bulk of the wiring, making it harder to handle and install. Thirdly, aluminum forms a layer of oxide on its surface, which can increase resistance and reduce electrical efficiency. This can lead to voltage drop and potential overheating issues. Fourthly, when aluminum wire is connected to copper components such as the panel, a galvanic reaction can occur, leading to corrosion and degradation of the metals. Fifthly, in most regions, electrical codes specifically prohibit the use of aluminum wire for boat dock applications due to safety concerns and the potential for corrosion. Given the significant safety risks and code violations associated with using aluminum wire on a boat dock, it is strongly recommended that you use copper wire for this application. Although copper wire may be heavier and more difficult to handle, it provides a stable, reliable, and code-compliant solution. When selecting copper wire for a boat dock, several factors must be considered to ensure safety and compliance with electrical codes. The appropriate wire gauge must be selected to handle the anticipated electrical load. Overloading a circuit can lead to overheating and potentially fires. Consult the National Electrical Code, Section 310.15 and subsequent tables, for ampacity ratings based on wire size and insulation type. The type of insulation is critical in a marine environment. THWN-2 or XHHW-2 rated wires are suitable due to their moisture and heat persistence. These insulation types are designed to withstand wet conditions and temperature variations common in boat dock applications. Grounding is essential for safety. A properly installed grounding system protects against electrical shock hazards. The grounding wire should be sized according to the overcurrent protection device in the circuit, as specified in NEC section 250.122. All metallic components of the boat dock, including the panel, should be bonded to the grounding system to ensure equipotential bonding. This minimizes the risk of voltage differences that could cause electric shock. All electrical connections must be made inside appropriately rated enclosures. These enclosures should be weatherproof and corrosion resistant to protect against moisture and salt spray. Proper sealing and gasketing are crucial to prevent water ingress. Use connectors and terminals specifically designed for marine environments. These connectors are typically made of corrosion-resistant materials such as tin-plated copper or stainless steel. Ensure that all connections are tight and secure to prevent loose connections, which can cause arcing and overheating. Ground fault circuit interrupters, or GFCIs, are mandatory for all outlets and circuits serving the boat dock. GFCIs detect ground faults and quickly interrupt the circuit to prevent electrical shock. They are crucial safety devices in wet environments. All circuits should be protected by appropriately sized circuit breakers or fuses. The overcurrent protection device should be matched to the ampacity of the wire to prevent overloading and potential fires. The electrical panel should be located in a readily accessible location but protected from the elements. The panel should be weatherproof and designed for outdoor use. Proper labeling of circuits is essential for maintenance and troubleshooting. Each circuit breaker should be clearly labeled with its corresponding load. All wiring should be properly supported and secured to prevent mechanical damage. Use cable ties or clamps to keep the wiring neat and organized. Avoid running wiring in areas where it could be subjected to physical stress or abrasion. Consider using conduit to protect wiring, especially in exposed areas. Conduit provides additional protection against physical damage and corrosion. PVC conduit is a common choice for boat docks due to its resistance to moisture and chemicals. Before energizing the system, thoroughly inspect all wiring, connections, and equipment. Verify that all grounding and bonding connections are properly made. Use a multimeter to check for any shorts or ground faults. After installation, periodically inspect the electrical system for signs of corrosion, damage, or wear. Replace any damaged components immediately. Test GFCIs regularly to ensure they are functioning properly. Keep the area around the electrical panel clear of obstructions to allow for easy access and maintenance. Consider hiring a qualified electrician with experience in marine electrical systems to perform the installation and maintenance. A professional electrician can ensure that the system is installed safely and in compliance with all applicable codes. Remember, working with electricity can be dangerous. Always energize circuits before working on them and follow all safety precautions. When dealing with aluminum wiring, it is imperative to understand its properties and how it differs from copper wiring. Aluminum has a higher coefficient of thermal expansion than copper, meaning it expands and contracts more with temperature changes. This expansion and contraction can loosen connections over time, leading to increased resistance and potential overheating. To mitigate this, use connectors and terminals specifically designed for aluminum wire. These connectors are typically made of aluminum or plated with a material that is compatible with aluminum, such as tin. They also incorporate features that maintain pressure on the wire connection to compensate for thermal expansion and contraction. When connecting aluminum wire to devices or components with copper terminals, use an antioxidant compound. This compound prevents oxidation of the aluminum and helps to maintain a good electrical connection. Apply the compound liberally to the aluminum wire before making the connection. Torque all connections to the manufacturer's specifications. Over-tightening can damage the wire or connector, while under-tightening can result in a loose connection. Use a calibrated torque wrench to ensure that all connections are properly tightened. Regularly inspect aluminum wire connections for signs of looseness or corrosion. If you find any loose connections, retorque them to the manufacturer's specifications. If you find any corrosion, clean the connection and reapply antioxidant compound before retightening. Aluminum wire is more susceptible to damage from bending and kinking than copper wire. Handle aluminum wire carefully during installation to avoid damaging it. Use proper bending techniques and avoid sharp bends. When pulling aluminum wire through conduit, use a lubricant specifically designed for aluminum wire. This will reduce friction and prevent damage to the wire insulation. Aluminum wire requires larger gauge sizes than copper wire to carry the same amount of current. Consult the NEC Table 310.15 to determine the appropriate wire size for your application. Be sure to consider the ampacity of the wire, as well as any directing factors that may apply. When splicing aluminum wire, use connectors that are specifically listed for use with aluminum wire. These connectors are designed to provide a reliable and long-lasting connection. Avoid using twist-on wire connectors, as they are not suitable for use with aluminum wire. When terminating aluminum wire at a circuit breaker or other device, follow the manufacturer's instructions carefully. Be sure to use the correct torque settings and antioxidant compound. Properly installed and maintained aluminum wiring can provide safe and reliable electrical service. However, it is important to understand the unique properties of aluminum wire and to follow all applicable codes and standards. If you are not comfortable working with aluminum wire, it is best to hire a qualified electrician. For boat docks specifically, the environment introduces additional challenges. Salt water is highly corrosive and can accelerate the degradation of electrical components. Therefore, extra precautions must be taken to protect the wiring and equipment from corrosion. Use only marine-grade electrical components that are specifically designed for use in saltwater environments. These components are typically made of corrosion-resistant materials such as stainless steel or bronze. Apply a corrosion-inhibiting coating to all electrical connections. This will help to protect the connections from corrosion and ensure a reliable electrical connection. Regularly inspect the electrical system for signs of corrosion. If you find any corrosion, clean the affected area and apply a new coating of corrosion inhibitor. Consider using a cathodic protection system to protect the metal components of the boat dock from corrosion. A cathodic protection system uses a sacrificial anode to protect the metal components from corrosion. The anode corrodes instead of the metal components, extending their lifespan. Ensure that all electrical equipment is properly grounded to prevent electrical shock hazards. Grounding is especially important in wet environments. Use ground fault circuit interrupters (GFCIs) on all circuits to protect against electrical shock hazards. GFCIs detect ground faults and quickly interrupt the circuit to prevent electrical shock. Keep the electrical system dry and free from moisture. Moisture can accelerate corrosion and create electrical hazards. Use weatherproof enclosures and fittings to protect the electrical components from moisture. Properly label all electrical circuits to make it easier to identify and troubleshoot problems. This is especially important in complex electrical systems. Follow all applicable electrical codes and regulations. Electrical codes are designed to protect people and property from electrical hazards. Consult with a qualified electrician to ensure that the electrical system is installed and maintained in accordance with all applicable codes. Electrical safety is paramount, especially in a marine environment. Taking these precautions can help to ensure a safe and reliable electrical system on your boat dock. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. Choosing the right type of wiring and adhering to proper installation practices is crucial for the longevity and safety of any electrical system, but particularly in demanding environments such as boat docks. Copper wire is generally preferred due to its superior conductivity, corrosion resistance, and ease of use. While aluminum wire can be used in certain applications, it requires special considerations and precautions to ensure safe and reliable performance. Always prioritize safety and compliance with electrical codes when working with electrical systems. When considering the longevity and safety of electrical installations in boat docks, it is critical to understand the effects of the marine environment. Saltwater is a highly conductive and corrosive medium, leading to accelerated deterioration of many materials, including metals used in electrical wiring and components. Copper, while generally more corrosion resistant than aluminum, can still suffer from corrosion in marine environments, especially when exposed to prolonged contact with saltwater. This corrosion can reduce the wire's cross-sectional area, increasing its resistance and potentially leading to overheating and failure. Aluminum is particularly vulnerable to galvanic corrosion when in contact with dissimilar metals, such as copper or steel, in the presence of an electrolyte like saltwater. This galvanic action can cause rapid deterioration of the aluminum, compromising the integrity of the electrical system. To mitigate these corrosion risks, several strategies can be employed. Firstly, use marine-grade wiring and components that are specifically designed to withstand a harsh marine environment. These components typically feature corrosion-resistant materials such as tin-plated copper, stainless steel, or specialized alloys. Secondly, apply a corrosion-inhibiting compound to all electrical connections and termination. This compound creates a protective barrier that prevents moisture and salt from reaching the metal surfaces, reducing the risk of corrosion. Thirdly, implement a cathodic protection system to further protect the metal components of the boat dock from corrosion. Cathodic protection involves using a sacrificial anode, typically made of zinc or aluminum, which corrodes instead of the metal components you want to protect. The anode is electrically connected to the metal structure, creating a galvanic cell that forces the corrosion to occur at the anode, rather than on the protected structure. Fourthly, regularly inspect the electrical system for signs of corrosion and wear. Pay close attention to connections, terminations, and any exposed wiring. Clean and repair any corroded areas promptly, and replace any damaged components. Finally, ensure that all electrical equipment is properly grounded to provide a safe path for fault currents. Grounding is particularly important in marine environments, as it helps to prevent electrical shock hazards. Use ground fault circuit interrupters (GFCIs) on all circuits to provide additional protection against electrical shock. Remember, electrical safety is paramount, especially in a wet environment like a boat dock. Always follow all applicable electrical codes and regulations, and consult with a qualified electrician if you have any questions or concerns. By taking these precautions, you can help to ensure the safety and reliability of your electrical system and protect against the hazards of corrosion in the marine environment.